Hello, good viewers. Welcome back once again. Today we have the following Oxford University entrance examination problem. We're given that x squared plus 3x minus 2 equals 0. Right over here, we are going to evaluate this quintic polynomial expression. X to the power of 5 plus x to the power of 4 plus 1. We're given that x is less than 0. Let's start by solving for the roots of this equation so that we can decide the root which is less than 0 or which is greater than 0. We have the given equation x squared plus 3x minus 2 equals 0. Now we're going to make use of the general quadratic formula. So here a will be the coefficient of x squared, which is 1. B will be the coefficient of x, which is 3. And c, the constant, will be negative 2. And from here we have x will be equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And when we substitute these values respectively, we get 3 plus or minus root of 17 all over 2. So from here we have the two values here. So we have x equals, this is negative 3, right? So we have x equals negative 3 plus root of 17 over 2. And we have x equals negative 3 minus root of 17 all over 2. But obviously this root here is less than 0, while this is greater than 0. Therefore, we don't necessarily need this in this case. So we are going to solve with this. So here we have that x is equal to negative 3. Let's split the denominator. Negative 3 all over 2 minus square root of 17 all over 2. Amazing. Okay, now from the given equation, we have x squared plus 3x minus 2 equals 0. Now this term here, 3x and negative 2, let's move it to the right hand side of this equation. But the signs will change, right? So here we have x squared equals, that will become negative 3x then plus 2. Okay, so from here let's go ahead and square both sides of this equation. Remember, we are asked to evaluate x to the power of 5 plus x to the power of 4 plus 1, right? And when we square both sides, we are going to get the value for x to the power of 4 in terms of x. Thereby substituting the value for x, then we can easily figure out the value for x to the power of 4, right? So here we have this equals negative 3x plus 2 squared. From the right hand side, we'll make use of this binomial expansion, right? Okay, so we have a plus b squared. This will be equal to a squared plus b squared plus 2ab. So from the left, let us make use of this property again. A to the power of b, then raised to the power of c. This can be rewritten as a raised to the power of b times c. So here this will become x to the power of 2 times 2, which is 4. Then this will be equal to, the first term squared will be 9x squared. Then plus the second term squared will be 4. Right? Then plus 2 times the first time times, that will be negative 12x, right? So from here, x squared is equal to negative 3x plus 2. So we're going to substitute. So we get 9 into bracket, negative 3x plus 2 plus 4 minus 12x. Now simplifying, opening this bracket and simplifying, we get x to the power of 4 equals 22 minus 39x. Okay, so from here let's solve for the value of x to the power of 4. We have here 22 minus 39 into bracket. Remember, x is equal to negative 3 over 2 minus root of 17 over 2. And from here we get 22 minus here 39. Negative 39 times negative 33 will give us positive 117. So that becomes plus 117 all over 2. Then negative 39 times negative root 17 over 2 will give us plus 39 root of 17 all over 2. So from here we have x to the power of 4 equals, now simplifying this properly, this will be the same as 44 all over 2. Then 44 plus 117 will give us 169. So we have 169 all over 2. Then plus, then 39 root of 17 over 2. Okay, that is the value for x to the power of 4. Okay, now let's continue. Now let us recall that x to the power of 4 equals 22 minus 39x. Now let's go ahead and multiply both sides by x. So x times x to the power of 4, this will be equal to x into brackets 22 minus 39x. Now the reason for doing this is because we are interested in solving for the value of x to the power of 5, right? Because x to the power of 5 is included in the expression we are asked to evaluate, as we can see it here. Okay, now from here, x here has a power of 1. So since we have the same base, we can add the powers. So we get x to the power of 5. This equals 22x, right? That is 22x, then minus 39x squared. And again, this equals 22x minus 39 into brackets. Now recall that x squared equals 2 minus 3x, right? 2 minus 3x, or negative 3x plus 2, anyhow you want to write it. Okay, so from here we have x to the power of 5 equals 22x. Now minus 39 times 2 here will give us negative, right? Negative 78. And then minus 39 times negative 3x from here. That's what we have, right? So negative 3x from here. So that's going to give us 117x, right? So we have here plus 117x. Okay, so from here, simplifying, we have here negative 78, then 22x plus this, that will give us 139x, right? So plus 139x. And again, we're going to find the value for x to the power of 5 here. We're going to make substitution. So we have negative 78 plus 139 into bracket. Remember, s is equal to negative 3 all over 2 minus root of 17 all over 2. Here we get x to the power of 5 equals here negative 78. Then here we have a 139 times negative 3 all over 2 will give us negative 417 over 2. And here we have minus this times this, that will give us 139 root of 17 over 2. So from here, we remember to simplify this. Now we need to multiply this by 2 all over 2 so that we can have equal denominator with this denominator here, right? And when you do that, we get 100 and, what do we have? Okay, 156, right? Then we are going to add it up with this. Is that 156? Hope I'm not making a mistake. So if you multiply this by 2, 16, 1, then here 14, then so we're going to have 156. No? Should that be 156? Yes. Okay, so whatever. Now when you simplify this properly, from here, we are going to have, okay, let's go ahead and do that first. We have x to the power of 5 equals, so from here, we have negative 1 56. Yes, then divided by 2. And here we have minus 417 divided by 2. And minus 139 root of 17 divided by 2. So from here, let's go ahead and add this. So we're going to have minus 156 minus 417 will give us negative 573. Then all over 2. Then minus 139 root of 17 all over 2. Amazing. So therefore, the expression we are asked to evaluate, x to the power of 5 plus x to the power of 4, then plus 1 will be equal to x to the power of 5 is equal to negative 573 divided by 2 minus 139 root of 17 divided by 2, then plus the value for x to the power of 4, which we got as 161 over 2, right? Then plus 39 root of 17 all over 2, then plus 1. Now let's go ahead and simplify this. So from here we have this equals, so from here we have this, so we have 1 plus 161 all over 2 from here. I think that's what we have from here. Okay, do not forget we still have negative 573 over 2. Then we're going to add it to 161 all over 2. So that will give us negative 412 over 2. Then remember we have 139, negative 139 root 17 over 2 plus this. That will give us negative 100 root of 17 over 2. And from here we have plus a 1. So from here this equals, so here, okay, so here we have to divide this out. So we're going to have negative 206, then minus here 50 root of 17, right? Then plus 1. So from here this simplifies to negative 205, then minus 50 root of 17. And from here we have the solution. So here we have x to the power of 5 plus x to the power of 4 plus 1 equals negative 205 minus 50 root of 17. Amazing. And this is approximately equal to negative 411.1553. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.